morning. Okay, so aldehydes. One minute. Aldehydes, ketones, we are going to discuss. And anyone can send me the message what we had discussed in the last class. Can any one of you? What we had discussed in the last class. Okay. Any one of you can tell me, or you have sent the message. I am putting the ink into this. What we have discussed. Wow. No one is telling anything? We were talking about oxidation, right? We were talking about the oxidation. So oxidation of what? Oxidation of aldehydes and ketones. So that's where we have the oxidation. Now, during the oxidation, with respect to aldehydes and ketones, what is the difference? With respect to aldehydes and ketones, with respect to oxidation, what is the difference? What is the difference between aldehydes and ketones with respect to oxidation? Fast. Okay. So the difference here is when it comes to aldehydes, they can converted into respective carboxylic acid. They will be converted into respective carboxylic acid even by using the mild conditions. Okay, we can use the oxidizing agent and we can maintain the mild conditions. But when it comes to ketones, we have to provide a harsh condition. What do you mean by harsh condition? So that is high temperature, strong oxidizing agents. Okay, so that is one difference. When it comes to the ketones, oxidation of ketones will be a bit difficult compared to the aldehydes. That's what this means. Okay, so now along with that, when it comes to the ketones, it will give the mixtures of carboxylic acid. Got my point? So that's where we have the differences between aldehydes and ketones. In both the cases, They will be converted into carboxylic acids, no doubt. But when it comes to the ketones, we have to provide a harsh condition. We have to maintain a high temperature. So then only it will get converted into carboxylic acid. So that is one thing. Now, after this, we had discussed about, so after this, where aldehydes and ketones got converted into carboxylic acid, no doubt, and the oxidizing agents like dichromate or permanganate or chromium trioxide, these can be used. Okay? Now, what is that? Next we have discussed. Any one of you? What else we have discussed? Yes, Jannavi. So we have discussed about tolerance reagent. Very good. So we have discussed about the tolerance reagent. Very good. So hagadre, what do you mean by tolerance reagent? So what do you mean by tolerance reagent? What you are going to give the answer? What do you mean by tolerance reagent? Ammoniacal silver nitrate solution. Very good. So tolerance reagent is nothing but ammoniacal. Okay. So tolerance reagent is nothing but ammoniacal silver nitrate. Very good. Silver nitrate solution. Very good. So that's where we have the tolerance reagent. Okay. So no doubt this is nothing but a tolerance reagent. So when I am talking about tolerance reagent, where it will be used? It will be used for the tolerance test. It will be used for the tolerance test. So what is the application of tolerance test? Tolerance test will be utilized to distinguish between aldehydes and ketones. To distinguish between aldehydes and ketones. Right? Yes, Sanjana. It is also called as silver mirror test, no doubt. It is also called as silver mirror test. So, hagadre, what is the application of tolerance test? It is used to distinguish between aldehydes and ketones. How they are going to distinguish? Which is going to respond for the tolerance test? Whether aldehydes or ketones? Which molecule is going to respond to the tolerance test? Whether aldehydes or ketones? Yes, Krishna, it is aldehydes. Aldehydes are the one which is going to respond to the tolerance test. Ketones will not go for tolerance test. Both of you are absolutely correct, Krishna and Sanjana. So when it comes to the tolerance test, it will be for aldehydes, which is going to react with the tolerance reagent. What is the reason? Why ketones, they are not going to respond to the tolerance test or tolerance reagent? Anyone? Why ketones, they are not going to respond to the tolerance reagent? What is the reason? Anyone? Why ketones will not respond to the tolerance reagent? You can just put one word. Okay. The reason here is tolerance reagent is a mild oxidizing agent. It is a mild oxidizing agent. Okay. So therefore, as mentioned earlier, whenever there is a mild oxidizing reagent, ketones cannot respond. So therefore, aldehydes are the one which can be easily oxidized even by using mild condition. So therefore, silver mirror test or tolerance test is meant for the aldehydes, and that's how they can distinguish between aldehydes and ketones, or that's where they can identify whether a given organic compound containing carbonyl group, whether it is a aldehyde or a ketone, because both the functional groups, they are having carbonyl groups in their structure, right? So that's where aldehydes are the only molecule or functional group, they are going to respond to the tolerance test. Okay, so ಹಾಗಾದ್ರೆ when I am talking about aldehydes, that's where we have the aldehydes. Now, ammoniacal silver nitrate, right? So that's where we have the AgNH3 twice. So plus 1, it will remain as it is, or you can simply write it as plus. Okay? So now, what is that plus indicates? Charge of the silver. Okay? So yes, Krishna, it will be conducted under basic condition. So that's where aldehyde group will get oxidized to carboxylate group and silver will be formed. Then there will be liberation of ammonia. Right? There will be liberation of ammonia. So what I mean to tell here is oxidation state, if you consider, that's where we have the carbon. So plus 1 with respect to aldehyde carbon, plus 3 with respect to carboxyl group carbon. So therefore, since there is a difference of 2, so therefore there should be 2 molecules which will be involved. With respect to ammoniacal silver, there should be 2 molecules. Now how many ammonia? So 2 2s are 4. So total 4 ammonia will be liberated. Now if you want to balance the charge, so here it is minus 1. So there it is plus 2. So to balance the charge, we will make it as 3OH minus. Already Krishna has told it will be conducted under basic condition. That's where OH minus 1, hydroxyl ion. So now 3OH minus 2 plus leftover is minus 1. So here also right hand side also we have the minus 1. Okay. Now we have to balance the water. Now we have to balance the water. See for example 3 2 are 6, 12, 13, then 16. 16 hydrogens are there on the left hand side. What about right hand side? So here it is 12. 12 hydrogens are there. So what is extra hydrogen we require? Extra hydrogen we require is 4. So we will make it as 2H2O. So we will make it as 2H2O. Fine. So whether I am clear? So that's where we have the tolerance test, where aldehyde group will get converted into carboxyl group. In this case it will be carboxylate because we are maintaining the alkaline condition, and silver ion plus 1 it is becoming 0. So silver ion from plus 1 oxidation state it is attaining 0 oxidation state. So that's where it will become insoluble, which will give the mirror type of appearance on the surface of the or on the sides of the test tube. So that's why it is called as silver mirror test. That's why it is called as silver mirror test. Okay. So this is with respect to tolerance reagent or tolerance test. So ಹಾಗಾದ್ರೆ with respect to this tolerance test, what is the condition they will maintain? Basic condition. And due to the mild oxidizing character, they cannot react with the ketones. But that day also I told, Now also I am telling, but when it comes to tolerance test, you should remember this one. When it comes to tolerance test, even fructose and glucose both will be responding to this test. So don't think that since fructose is a ketose. What do you mean by ketose? Ketone group containing sugar. And glucose is a aldose. So don't think that fructose and glucose can be distinguished by using tolerance test. No, that will be a wrong statement. Okay? Because under alkaline condition, both fructose and glucose, they will attain a common type of intermediate. Due to that, even fructose, although it is ketone containing molecule, it will respond to the tolerance test. Whether I am clear? Fine. So don't think that fructose and glucose can be distinguished by using tolerance test. No. But all the other aldehyde containing organic compound and ketones containing organic compound can be distinguished, but not sugar, especially fructose and glucose. Fine. So then we were discussing about Fehling's. Then we were discussing about Fehling's reagent. Okay. So once again, I will make it as very important. Fehling's reagent. So already we have discussed about reagent A. If I am right, already we have discussed about reagent A and reagent B. Can any one of you tell me what is reagent A? Fehling's reagent A, 2 marks question. What is Fehling's reagent A and B? 2 marks question can be asked. Aqueous copper sulfate. Oh, very nice. It is nothing but aqueous copper sulfate. Okay? That is aqueous copper sulfate solution. This should be your answer. So what do you mean by aqueous copper sulfate? Aqueous copper sulfate means it is copper sulfate dissolved in water. Okay? Now, reagent B, Krishna, something I told to remember, one word. Sodium potassium tartarate, yes, fine, but something I told to remember. What is that? Reagent B. Yes, it should be alkaline. Okay? So it should be alkaline sodium potassium tartarate. Sodium potassium tartarate solution. What do you mean by alkaline? Alkaline means basic condition. They are maintaining the basic condition. They will use sodium carbonate, which is a mild basic compound, or they can use a dilute sodium hydroxide. So that's where alkaline condition will be maintained. They will be maintaining the alkaline condition. So that's where sodium potassium tartarate solution will be used. So this word has to be written. Okay? So that's why we have the reagent A and the reagent B. Now while doing the experiment, they will take equal amount of A and B, and they will mix and they will use that one as a Fehling's reagent. They will mix equal amount of reagent A and reagent B, and they are going to use it as a Fehling's reagent for further reaction. Alone as reagent A or alone as reagent B, they cannot give any reaction with the aldehydes or ketones. Okay? So they have to mix in equal proportion, then they can be used as a Fehling's reagent. Fine? Whether I am clear? So whenever it is required, that time they will mix this reagent. Fine. Now when it comes to sodium potassium tartarate, that is reagent B. So that is the one which is going to stabilize the cupric ion. What is the role of sodium potassium tartarate? It's going to stabilize. It is going to stabilize the cupric ion. Cu plus 2 cupric ion during the reaction. It is going to stabilize the cupric ion during the reaction. That's why sodium potassium tartarate they will use. They are not going to involve in the reaction with aldehydes. Please remember, sodium potassium tartarate, they are not going to involve in the reaction with aldehydes, but they are required to stabilize the cupric ion. Because what is copper sulfate? Copper sulfate is nothing but plus 2 SO4 minus 2. Right? So copper sulfate will be present in water as cupric ion and sulfate ion. Okay, that's why it is called as cupric sulfate. We can call it as cupric sulfate to be more appropriate. We can call it as cupric sulfate. So that's where we have the copper sulfate or cupric sulfate. Cu plus 2. Fine? Right? This cupric ion is the one which is going to involve in the reaction. Not sulfate, not sodium potassium tartarate. It is the cupric ion in the presence of alkaline condition. They are going to involve in the reaction with aldehyde. So whether I am clear? So if you further write the reaction, nowhere we will find sulfate or sodium potassium tartarate because they are not involved in the reaction. Fine? Any doubt? Okay. So what is that reaction? Naturally it should be aldehyde with copper sulfate. I will take it as plus 2. Copper sulfate I will take it as plus 2. Okay. Now it's going to react with aldehydes under alkaline condition. So we will maintain that one as OH minus under alkaline condition, where cupric ion will get converted into cuprous form. A cupric of copper will get converted into cuprous form. Okay. So now another product will be naturally carboxylate. Another product will be carboxylate. Since OH minus is on the left hand side, I will write water on the right hand side. Still we are not balanced with the equation. Okay. But I want first you to understand. So what will happen to the copper? So whatever cupric ion is there, it will convert it into cuprous form. So that means plus 2 it will become plus 1. Don't write this equation, I will write the equation. Okay. Now this is plus 1 and here it is plus 3. What will happen to the cupric ion? How many cupric ions are required? Any one of you? How many cupric ions are required? Aldehyde carbon from plus 1 it is becoming plus 3. So cupric plus 2 it is becoming cuprous form. So how many carbons are required? How many copper ions are required? Any one of you? You can just mention the number. Yes, Sanjana. Very good. So 2 are required. So 2 are required. Okay, that's where based on the electron equation is balanced. But what about charge? So 2 2s are 4 plus 4 minus 1. So here it is minus 1. So if you make it here also minus 1, then the equation will be balanced. Now how to balance? How many OH minus I should have? The right hand side plus 1 is also there. If you take cuprous ion, don't write this one. Cuprous ion will not be present as it is. To make you understand, okay, otherwise I will balance what is actually the equation is. CHO. So this is just to make you understand. So cupric ion, then OH minus, then one of the product is RCOO minus. Now observe me carefully. I told cuprous ion will not be found as it is. Whatever copper with plus 1, it will be present as, what is this? Cu2O. What is Cu2O? Anyone of you? What is Cu2O? Upper equation, I wanted to tell you that Cu plus 2 is becoming Cu plus 1. That's all. Cu plus 1 will not be present as it is. It will be present as Cu2O. So what is Cu2O? Yes, very good. Both of you correct. It is cuprous oxide. Very good. It is cuprous oxide, which will form a reddish brown precipitate. It will form a reddish brown precipitate. So if the color is changing, initially copper sulfate, right? Blue color, sky blue. If it is getting changed to reddish brown color, that indicates that the given organic compound is a aldehyde group containing organic compound. So that's where reddish brown precipitate of cuprous oxide will be formed. Oxide, oxygen with -2, right? So that's where, therefore, 2 copper are there, it will be +1. So from +2 to +1. Now we can balance the equation. Okay, this is actually the real equation. To make you understand what is happening to copper, I wrote it as Cu plus 1. But it will not be present as Cu plus 1, it will be present as a compound that is called as cuprous oxide. Okay, so can you balance the equation? So here naturally 2 cupric ion is required. Right hand side no change because already 2 coppers are there. So on the right hand side no change. Already 2 coppers are there. Only on the left hand side it should be written as Cu plus 2. Okay na? So in that case 2 2s are 4 plus 4 charge. Right hand side -1 is there. Here -1 is there. What we have to do? How many hydroxyl ion we should take? Just send me the number. How many hydroxyl ion? Okay, Krishna, if I take 3 OH minus, okay, so then +1 will be remaining here. So already I have +4. So already Sanjana, both of you. Okay, fine. So if I take 3 negative, 3 OH minus, here already 4 plus, so leftover one will be +1. But right hand side it is -1. Okay, now you are correct. Better to take 5 OH minus 1. That is because leftover will be -1. Leftover will be -1. Same as that of the right hand sided one. So -1. Okay. So what will be the water? What will be the water? How many water molecules? So water molecule should be based on hydrogen. Yes, it should be 3. 3 molecules of water. Why? Because 5, 1, 6 hydrogens are there on the left hand side. So therefore on the right hand side we should take 3H2O. Yes, all of you correct. So what I mean to tell here is we have to use hydroxyl ion as we know to balance the charge, and we have to use the water to balance the hydrogen and oxygen, majorly for hydrogen. Fine, that's where we have the Fehling's test. So what is the end result of Fehling's test? End result of Fehling's test is, if there is a presence of aldehyde, naturally there will be formation of reddish brown precipitate, or solution will get converted into reddish brownish color. So the reason is due to the formation of cuprous oxide. So whatever cupric ion is there, from +2, copper will get changed to +1 oxidation state. Okay. Now another once again important statement here is, Fehling's test, even fructose will respond. Same as that of the tolerance reagent, here also fructose is going to respond to the Fehling's test. Fine. So that's where we should understand it. Same as that of the tolerance test, where Fehling's and glucose cannot be distinguished from each other. Same way, even Fehling's test cannot be used to distinguish between fructose and glucose, because both will give the reddish brown precipitate. But whether you take tolerance or whether you take Fehling's, both can be used for the quantification of glucose or fructose. For the quantification of glucose or fructose. What I mean to tell you is, what is that amount of glucose? What is that amount of fructose which are present in a given solution? That concentration can be measured by these two tests. Fine? But in general, we can tell that tolerance test and Fehling's test can be used to distinguish between aldehydes and the ketones. All of you got my point? So, hagadre, which is the oxidizing agent in the Fehling's test? Which is the oxidizing agent in the Fehling's test? Any one of you? Which is the oxidizing agent with respect to Fehling's test? Yes, very good, Sanjana. So what I mean to tell you is, if I want to see, in case of the tolerance test, okay, so oxidizing agent is ammoniacal silver. Okay. So hagadre, what is the reducing agent here? Which is that reducing agent in tolerance test? That is aldehyde. Aldehydes. What is the condition we are going to maintain? We are going to maintain the basic condition or alkaline condition. Okay, we are going to maintain the basic or alkaline condition. Yes, Sanjana. Now, same way when it comes to Fehling's test or Fehling's reaction or test, we will go with Fehling's test only. Okay, so when it comes to Fehling's test, so what is that? Oxidizing reagent is cupric ion, aqueous cupric ion, which has been taken in the form of copper sulfate. Okay, so which is the reducing agent? Naturally it is same, aldehydes. However, the condition is once again alkaline. But what is the end result? What is the end result? End result with respect to tolerance test is formation of silver mirror. Formation of silver mirror. In this case, Fehling's test, reddish brown. Precipitate of Cu2O, that is cuprous oxide. Reddish brown precipitate of cuprous oxide. Okay, Dheeraj, from first it will be open. Okay, January 1st. Why suddenly you got That one, that doubt. Okay, it will be from first Dheeraj. Whether I am clear? This is where we have the tolerance test and failings test. So that's where they differ, and that's where they have the similarity. Which is that similarity? Both will be used for the identification of organic compound containing aldehyde group. Both will be carried out under alkaline condition. Under both the condition, aldehyde group is the one which will act as a reducing agent. Okay, so that's where we have the two important reactions. Fine. Next we will go with haloform reaction. I will mention this one as important. Next one is haloform reaction. But once again I will tell whether to take aldehydes or ketones with respect to sugars, especially fructose and glucose and all. They cannot be distinguished by either tolerance test also or failings test also. Okay. Now we will come to next reaction, which is called as haloform reaction. What do you mean by haloform? Which people have studied in the first organic chemistry topic, that is haloalkanes and haloarenes. What do you mean by haloforms? You can just give me the example. Haloform. Haloform reaction I have written, so that's why. What do you mean by haloform? Any one of you? Okay. CX3H. Okay. Iodoform, chloroform. Yes, Purnima. Even Krishna, you are also right. So when I am talking about haloform, in the name itself it is there. Halogen. Halogen with one carbon. Formic acid. Formaldehyde. Right? Same way we have the haloform. Yes, it can be a chloroform. Can be one of the example. CHCl3. So that's where we have the chloroform, which will be used as one of the important reagent as an organic solvent in a laboratory. Okay, so that's where we have the chloroform, which is used in paint industry. At the same time, they are toxic also. Anyway, all these things we have studied in our haloalkanes and haloarenes topic. So chloroform, then we have the iodoform. Like that we have the bromoform. Okay, iodoform will be used as an antiseptics. So that's where we have the haloforms. Naturally, when I am telling haloform reaction, it deals with the formation of these compounds. It deals with the formation of these compounds. Got my point? So naturally, when I am talking about haloform reaction, it will be with respect to ketones. It will be with respect to ketones, not with respect to aldehydes. It is with respect to ketones. Okay? Now if I want to go with a general equation, then I will take CO, CH3. Fine? Now, when this compound, if this ketone is treated with, it is treated with sodium OX. What do you mean by NaOX? Where X, if I take, where X can be equal to chlorine, bromine or iodine. Where X can be equal to chlorine, bromine or iodine. If I take NaOCl, what is this compound? What is this compound, NaOCl? If people have studied in P block elements, even in first PU, S block elements. What do you mean by NaOCl? Sodium hypochlorite. Very good. So that is nothing but sodium hypochlorite, not chloride. Chloride. This is important. Don't write it as De. Because when I am talking about this one, we have Na plus ClO minus. Chloride ion. So chloride means Cl minus. This will become chloride. But when I am telling ClO minus, it is chloride ion. Hypochlorite ion. Sodium hypochlorite. Okay. So now sodium hypochlorite is well known as, anyone? Sodium hypochlorite? Yes, Sanjana and Brunda. Both of you are correct. So sodium hypochlorite is well known as, anyone? Any one of you? Sodium hypochlorite is well known as? It is well known as bleaching agent, or to be more particular, it will be known as liquid bleach. It is known as liquid bleach because we have calcium hypochlorite. These things you should remember. Calcium hypochlorite. Naturally, I should take twice because hypochlorite is -1. So calcium hypochlorite will be sodium salt of carboxylic acid. Which one? Hypochlorite? No. It's not sodium salt of carboxylic acid. No. About which one you are telling? Okay, it's not a carboxylic acid. Calcium hypochlorite, it is called as bleaching powder. It is called as bleaching powder. So what I mean to tell here is NaOCl, it is sodium hypochlorite because hypochlorite -1. So Na plus. But when it comes to calcium hypochlorite, chloride should be twice because calcium will have the +2 charge. Sodium hypochlorite will be called as liquid bleach and calcium hypochlorite will be called as solid bleach or bleaching powder, which we commonly used, which we used to use at our home. That is bleaching powder. That is calcium hypochlorite, not sodium hypochlorite. Bleaching powder. But in some cases, bathroom cleaner and all, it will come in liquid form. That will be sodium hypochlorite. Okay? So that's where we have the molecule. Oh, okay, Brinda, I didn't see. Now I am saying. You have written sodium hypochlorite, not De. It should be Te. It is ClO minus, not Cl minus. It should be Te. Okay? So that's where we have the sodium hypohalite. General name can be sodium hypohalite. If I take Cl, X as Cl, then sodium hypochlorite. If X is Br, sodium hypobromite. If it is iodine, sodium hypoiodite. Got my point? So that's where we have the molecule. So it should be Te, not De. So hypohalite, not halide, De. No, it is Te. So that's where we have the ketones. Sorry, when it's treated with sodium hypohalite, now there will be formation of one of the product as. Now there will be formation of one of the product as CHX3. That is halo form. That is halo form. So what will be the another product? Oh, okay, you were talking about the product, I think then. Brinda, right? So what will be the another product? I think you were talking about the product. So the another product will be as Brinda, she has written sodium salt of carboxylate. Sodium salt of carboxylate. To remember this one, what you can do is the bond will be split here. The bond will be splitted here, and these among these two hydrogen will be splitted. Among these two hydrogen will be splitted. That's where this bond is going to broken. Okay, so O will directly come here. To make you understand this one, don't write everything in your answer script. This is not the exact way the reaction will be happening. In the beginning, hydrogen will be removed and halides will be attached, and at the end bond will be clipped, not in the beginning itself. But to make you understand, I am writing this one. Okay, since we have taken halo form, 3x is there, so here also we will make it as 3. Okay, so here also we will make it as 3. Fine. All of you have understood? Any doubts with regard to balancing is not a requirement. You can just write the product. That's where we have the halo form. Now can you tell me, if I want chloroform, which sodium hypochlorite I should use? If I want chloroform as the product, which sodium hypohalite I should use? If I want chloroform as the product, which hypohalite I should use? Sodium hypohalite. Which one? Yes, it should be sodium hypochlorite. If I want iodoform, then I should use sodium hypoiodide. So depending on the requirement, see for example, I can use NaOCl or NaCl also you can write, no problem. NaClO or NaOCl, anything is fine. Okay, so then the product will be sodium salt of carboxylate, but another product will be chloroform. If I take NaO iodine, then I am going to get sodium salt of carboxylate, respective carboxylate, and CH3. So that's where we have the iodoform, and that's where we have the chloroform. So depending on which type of haloform, we have to carry out the reaction by using respective reagent. Okay. Now, what is the basic requirement with respect to ketones? What is the basic requirement with respect to ketones? Any one of you? What is the basic requirement with respect to ketones? Can any one of you tell me what is the basic requirement with respect to ketones? All the ketones cannot be used. What is that basic requirement? Anyone? On the board itself it is there. The basic requirement here is we have to have a ketone which will be having one of the alkyl group as methyl group. So we can use methyl ketones only. No other ketones will have the haloform reaction. It should be methyl ketones. That is the compulsion. So methyl ketone should be taken. This R can be anything, but on one side there should be a methyl group. One side of the ketone should be methyl group. Yes. Yes, Brenda. We require methyl ketone, that is the compulsion. So that's where we have the haloform reaction. So what is haloform reaction? Haloform reaction is nothing but where, okay, what do you mean by haloform reaction? Haloform reaction means that's where we have the methyl ketones when react with sodium hypohalite, there will be formation of the respective haloforms. It can be chloroform or it can be iodoform, anything. So that's where we have the reaction. Okay? So that's where we have the haloform reaction. Any doubts with regard to this one? If you have any doubts, you can ask. Otherwise, I will move to the next one. Okay. So next one, I can mention it as very important. Okay. So that means aldol condensation. Aldol condensation. Okay. Now you should tell me what do you mean by condensation? What do you mean by condensation? Aldol condensation. So condensation means two organic compounds will be joined. Okay, two organic compounds will be joined. So that's where we have the, okay, done. Yes, Krishna, absolutely correct. Joining of two organic compound, that is generally called as condensation. Okay, so don't go with a regular term, because even a rainfall is due to condensation of water, moisture, right? So that's where condensation in organic chemistry, that means we are talking about joining of two organic compounds. Fine, that is one part. Aldol condensation. Now we are specifying that joining of two organic compound containing carbonyl groups. Okay? So what do you mean by aldol condensation? Aldol condensation is nothing but joining of two organic compound which contains carbonyl groups. That's why it is called as aldol condensation. Okay? Now, if you see the name, in the name itself it is there, in the product or in the intermediate, we will be having a condition where aldehydes and alcohol, both the groups will be there. In the intermediate, both aldehydes and alcohols will be there. Therefore, they are called as aldol condensation. As an intermediate, will be having aldehyde and alcohol group containing molecule after the condensation. Now, you might be having a question that, sir, whether it is applicable only for the aldehydes. No, even ketones will show the reaction. We can call them as aldol condensation, or to be more specific, we can call that one as ketol condensation. But generally, we will call it as aldol only. With respect to ketones, there will be formation of ketol. So what do you mean by ketol? Same as that of the aldol, where ketone and alcohol groups will be there in the intermediate. So that's why they are called as ketol. But when we are talking about overall reaction, we will not use the term ketol condensation. We will keep the term as aldol condensation only. Fine? Whether I am clear? Any doubts with regard to this one? So what I mean to tell you is, when I am talking about aldol condensation, it is nothing but combining of two organic compound containing carbonyl group. So carbonyl group means what? Carbonyl group means this one. So naturally both aldehydes and ketones, they are having carbonyl groups, right? So therefore there will be a aldehyde containing group which can be condensed, or ketone containing groups which can be condensed. If there is an aldehyde group, there will be formation of aldehyde and alcohol containing compound as an intermediate. If it is ketone, there will be formation of ketone and alcohol group containing intermediate. So that's where that intermediate can be called as aldol or ketol. But overall, the reaction will be called as aldol condensation. Any doubts? Anyway, I will stop here. If you have any doubts, you can ask. In tomorrow's class, we will go with the reaction for aldol condensation. But if you have any doubts, you can get it clarified. This is bit important even for your competitive exams. Okay, no doubts? Thank you very much. Take care.